I'm going to be talking about rational inequalities, and what I'm going to be doing is going to be based on these steps right here. Okay? Find critical points. 1, denominator based. You'll set the denominator equal to 0 and solve. Others, set the inequality as an equation and solve. Plot the real value critical points on a skeletal number line. For denominator-based critical points, always use an open dot, no matter what. The other critical points will depend on the inequality sign, like for other inequalities. Plot them on the critical points on a number line. Divide into regions. I use Roman numbers. We'll test each region. Pick a test value in the region, not a boundary, not a critical point, not a boundary point. A point that has a value that's in the region. Plug it in. Check to see if the result is true or false. Shade the true regions and describe the shaded regions. Okay? So, here's what I got over here. X minus 8 over x plus 5. Do critical points. Denominator and other. Denominator and other. So the denominator, x plus 5 equals 0. So I have x equals negative 5. And that's going to be an open dot for denominator critical points. Okay, so it's always going to have an open dot. Okay, the other critical point will be found by solving the inequality like an equation. So I'll have x minus 8 over x plus 5 equals 0. Okay? The inequality, but I treat it like a 0. Okay? Give me a moment. This thing is back on autofocus, and that doesn't result in good things. Okay, so let me get this thing set up the way it needs to be set up. All right, so it's on a manual, I think. No, it's not on manual yet. All right. Okay, so here goes. So I have x minus 8 over x plus 5. I recommend converting it into a proportion by setting any whole number or integer over 1. Okay? That will allow me to take this times this, so 1 times x minus 8 equals 0 times the x plus 5. Many students are familiar with proportions, and this works well for them. So this will be x minus 8, and that's 0. So add 8, x is 8. Okay, and that critical point will be graphed with a closed dot because of the or equal to in the inequality sign. Okay, so now we're going to plot these on a number line and test regions. So I have negative 5 is going to get an open dot. And I have 8. Region 1 over here, region 2 over here, and region 3 over here. Okay? So, we're going to test x minus 8 over x plus 5 greater than or equal to 0. Okay, that's what we're going to test. So, in region 1, I need anything that's less than negative 5. Negative 5.001 could work. Or negative 6, negative 7, anything that's less than negative 5. So I'll stick close, negative 6. X equals negative 6. So I want to know if negative 6 minus 8 over negative 6 plus 5 really is greater than or equal to 0. That's a question mark. Okay? So that's negative 14. That's negative 1. 14 over 1, well, that's just 14. Okay, this is just 14. So 14 greater than or equal to 0 is true. Okay? Now, region 2 has 0 in it. So because region 2 has 0, I'll use 0. Okay? So I want to know if 0 minus 8 over 0 plus 5 really is greater than or equal to 0. Okay, so that's negative 8, that's 5. By the way, that's a question mark. Okay, well, that's a negative number. That's false. There's no way a negative number can be greater than or equal to 0. Okay, so now I'll go on to region 3. Region 3. I'll use x equals 9. Okay, so I want to know if 9 minus 8 over 9 plus 5 really is greater than or equal to 0. That's 1. That's 14. That's true. Because 1 positive 1/14 is greater than or equal to 0. So here's what we have when it's all said and done. Negative 5 and 8, region 1, region 2, region 3. You don't have to relabel them if you don't want to, but I will. Region 1 was true, and region 3 was true. So describe that using interval notation. I would have negative infinity up to negative 5, or union, 8's included, all the way up to infinity. Okay, that's what you would have in interval notation. All right, I'm going to pause here and set up example 2. All right, so I have x minus 13 over x plus 7. Or x minus 13 over x plus 5 is greater than or equal to 7. Okay, so first thing we're going to do is the critical points. Critical points. Okay? Denominator. And other. So denominator critical point will be x plus 5 equals 0. So subtract 5, x equals negative 5. This will be an open dot. Okay, this will be an open dot because it's a denominator critical point. Okay? Now to find the other critical point, I would solve x minus 13 over x plus 5 equals 7. Okay? I would solve this in an equation. Many students are used to this method for solving this type of equation. That's what we'll use. So this will be 7 over 1. And then, so I convert this into a pair of fractions. So I can take 1 times x minus 13 and 7 times x plus 5. So 1 times x minus 13 1 times the x minus 13 equals 7 times the x plus 5. Like so. Okay? So I have x minus 13 equals 7x plus 35. I will subtract the 7x from this side so that I can get my x's to one side. Negative 6x minus 13 is 35. Okay? I will then add the 13. And I have negative 6x is 48. Okay? Divide off the negative 6. And x equals negative 8. Okay, and that's going to be a closed dot because of the or equal to in the inequality. Okay? So, here's what I'm looking at. I have -5 and -8. Region 1, Region 2, Region 3. Okay? And it's time to test the regions. Test. So region 1, I'll let x equal -9. So I want to know if -9 minus 13 over -9 plus 5 is greater than or equal to 7. Okay, that's what I'm trying to find out. And calculators can come in handy for some of this. This would be -22 this would be -4. Well, that's +5. That's going to be that would reduce this as +11/2. And that's actually 5.5. (5.5) greater than or equal to 7 is false. Okay? Region 2. Well, I could either use -7 or -6, or -6.5, or -5.1, or -7.9, or something of that nature. I'll do -7. So, -7 minus 13 over -7 plus 5. I want to know if it's greater than or equal to 7. That's the question. Okay, so that's -20. And that's -2. So is 10 greater than or equal to 7? That's true. Okay? So region 1 is false, region 2 is true. Now I'll do region 3. I'll let x equal 0 since region 3 has 0. So I want to know 0 minus 13 over 0 plus 5 is greater than or equal to 7. That's the question. Okay? So I have -13 over 5. All right, well that's negative, folks. That's impossible. Okay? If I convert it to a decimal, it'd be -2.6. That's false. There's no way a negative number is greater than or equal to 7. So here's what I'm looking at. All right, I have -8 as a closed dot. I had 5, it had -5, it had an open dot. And the only region that was true was region 2. Region 1, region 2, region 3. Okay? And I would describe this as lower limit -8, upper limit -5. And because -8 was included, it gets a square bracket. Since -5 is excluded, it gets around a parenthesis. And that is your solution. All right, I'm going to pause and set up for another example. All right, continuing. Here's an example that is not on the source document. We have 12 over x plus 4 is less than or equal to 10 over x minus 2. So here we go. The first thing we have to do is the critical points. There's the denominator, and then there's other. So denominator critical points, we have two denominators. So I have I have to find x plus 4 equals 0, and x minus 2 is 0. Both of these are denominators, so both of those have to be done as denominator critical points. I'm going to write them more largely. That may not be proper English, but it communicates. So denominator and other. So x plus 4 minus 0 equals 0 gives me x equals negative 4. And then add the 2 back, and x equals 2. And remember, these get open dots because they are denominator critical points. Okay? Now over here, I have, just to get the other critical points, or other critical point, I solve this as an equation. Okay? It's a proportion, so I can simply do, I'm going to copy it twice. Okay, I can do this times this equals this times this. So we got 12 times x minus 2 equals 10 times x plus 4. Okay, this times this equals this times this. So 12x minus 24 equals 10x plus 40. Okay, I will subtract the 10x. And I have 2x minus 24 is 40. Okay? Add the 24 back. And 2x is 64. Divide off the 2, divide off the 2, x is 32. And that's going to get a closed dot because of the or equal to in the sign. Okay, so now it's time to plot the points on the number line and test the regions. Space will be at a premium, so I'm going to go all the way up here. Okay? I have negative 4, 2, and 32. And those two were open dots. Okay, and 32 is a closed dot. This doesn't have to be to scale. So I have region 1, region 2, region 3, and region 4. IV. Okay, so it's time to test. Test region 1. I'll let x equal negative 5. Okay, so I have 12 over negative 5 plus 4. I want to know if it's less than or equal to 10 over negative 5 minus 2. Okay, so that's going to be 12 over negative 1. By the way, that's a question mark. We don't know that. That's going to be 10 over negative 7. And that's negative 12. And I'll use a decimal approximation. It's the positive divided by a negative. Go ahead and put negative 12. Negative 12. And then I want to, that's still a question mark. And then negative 10 divided by 7 is approximately negative 1.42857. So that's true. Okay, that's true. Region 2. Region 2 is right here, and it has 0. So since it has 0, we'll use 0. So we have 12 over 0 plus 4. Oh, I want to know if it's less than or equal to 10 over 0 minus 2. Okay? Well, that's 12 over 4. That's 10 over negative 2. So that's 3. Just a little question mark. 3 less than or equal to negative 5. That's false. Okay, that's not true. Okay, so next I'll move on to region 3. And x equals 3 would be a good test point. So I'll use 12 over 3 plus 4. I want to know if it's less than or equal to 10 over 3 minus 2. Okay? So that's 12 over 7. And that's 10 over 1. So if it's not clear enough already, I'll do 12 divided by 7, and that's approximately 1.7. 143, and that's 10. Okay? Well, that's true. Okay? And then finally we have region 4. I'll use x equals 33. Okay, so I have 12 over 33 plus 4. I want to know if it's less than or equal to 10 over 33 minus 2. Okay, so that's 12 over 37. By the way, I need a question mark there because I don't know that for sure. And then 10 over 31. We will use decimal approximations for this. 12 divided by 37 is 0.3243. Okay? And then 10 divided by 31 is approximately 0.32258. Okay? It doesn't really have, just make sure you go out enough decimal places to tell the difference. I want to know if this is true. And folks, this is false. Okay? The 3 2's are the same, but this 2 is actually, this 2 thousandths is actually less than the 4 thousandths that you have there. So this is actually false. So here's what we're looking at in terms of regions that are ready to be, that can be shaded. We have negative 4, we have 2, and we have 32. Okay? This was region 1. This was region 2, this was region 3, this was region 4, okay? You don't have to relabel them if you don't want to, but region 1 was true, and region 3 was true. So we would describe that as negative infinity to negative 4, union 2, because 2 wasn't included, it's got an open dot, 2 to 32. 32 is included because of the closed dot. All right, and that is it.